All right, pH and solubility. So pH is high, hydroxide's high. pH is low, hydronium is high. So we need to think of how are these going to be impactful for what we have. Solubility of an ionic compound with a basic anion will increase with increasing acidity because the fact that you have more hydronium or hydrogen ion in solution at a lower pH means it's going to kind of gobble up more of that hydroxide, which is going to shift it to being more soluble. So some common basic anions are ever so famous hydroxide, sulfide ion, and carbonate ion. Now, there is no compound that adds acidity, so we always want to look at the anion to see what kind of base it is and see if that's going to be more soluble in an acidic solution. So is it going to be more acidic or not? So let's take an example. Iron 2 carbonate, lead 2 bromide. Which is more soluble in acid than base? Why? So let's take a look at the first one. We're looking at the anion. I see carbonate. Common base. Because we have the idea that carbonate plus acid is going to make hydrogen carbonate, that means having more hydrogen will shift it to the left, removing carbonate ion from solution, which will lower the common ion of carbonate. That increases the solubility. Because remember, this breaking down is going to be producing iron 2 ions and carbonate. If we have more hydrogen ion in solution, a lower pH, that's going to take carbonate out of the solution and therefore make more of this dissolve. Br minus is not a base. Yes, it is a conjugate base of the strong acid, but it's pH neutral. So that's why this will not have any change in acid. Determine if each compound is more soluble in acidic solution than pure water. So we've got our different areas. So mercury 1 bromide will not be more soluble because, again, Br ions will not react with acidic solutions because this is a strong acid. So you say, well, come together, but then break apart because strong acids fully dissociate. Magnesium hydroxide. So we have hydroxide. It's basic. It will be more soluble. Can be converted to water. So this species is not hydroxide, doesn't appear in the KSP expression. So the idea is that when you make more water, all you're doing is decreasing the concentration of the hydroxide, in which that means more and more is going to be more soluble. So it's like if you had the KSP value of Mg2 plus and OH minus, I guess that would be on top, right? Because they're products. Just take away hydroxide. If you take away hydroxide, that means more of the magnesium hydroxide will need to be dissolved in order to keep up and keep that KSP value the same. Calcium carbonate, more soluble because this is basic, can be converted to the hydrogen carbonate ion and carbonic acid. These are not CO3 2-, they don't appear in the KSP expression. So therefore, again, that's going to draw out more of that carbonate ion, meaning more can be soluble. AgI, again, we're looking at the anion. I- won't react because HI is a strong acid. It's not going to be pulled out of solution. It's just going to stay there and continue to not join with hydrogen. All right, get some practice on these. Let me know what questions you have. We've got one more to go. Take care.